Hi everyone. So today we're going to work on simplifying, multiplying, and dividing rational expressions. So this you're going to find easier than graphing, I would think, and it's all about the factoring. So if you can factor, this is going to be a walk in the park. So basically when a rational expression we're going to say is basically it's your same thing as a rational function, where functions we talk about graphing and expressions we talk about doing the operations with. There's not equal to a y value or anything like that. It's just your quotient of your two polynomials. So you have your p of x and your q of x, and again, q of x cannot equal 0. So something like 4 minus x over x squared minus 16 would be considered a rational expression. Now, the simplest form is when the numerator and denominator of your polynomials have nothing in common. So if I take a look at this 4 minus x over x squared minus 16, I'm going to want to factor to see if they have any common factors. So the denominator is going to be x minus 4, x plus 4. And the numerator, well, I don't like the way that's looking. I don't like the fact that my negative sign is in front of my variable and the variable second. I'd like to have this rearranged. So I'm going to use my commutative property to rearrange that. And, oh, that would look out great. I'm going to factor out negative 1. Because now, if you notice that the x minus 4 is now a common factor, which means this is not in simplest form. So like we did the other day, we're going to be able to reduce this out because multiplication, remember when you reduce a fraction, we're dividing a number, or even in this case an expression, out, which means that we need to have multiplication happening to be able to divide. So our final answer, our reduced form, our simplest form, is negative 1 x plus 4. Now again, we should probably say that you can't have a negative 4 in the bottom, and if I go back to the original, you can't have 4 either. Okay, and this is what we're going to work on today. All right, so I have some steps for us on simplifying. Key to life here is we're going to want to factor. So we want to factor both the numerator and denominator. Okay, so remember that means that you're going to do GCF, factor, like your normal factoring for trinomials. I don't remember what we call that. Split distribute, box. Let's just call it split distribute. Reverse, whatever you want to call it. Okay? All right, but GCF always should come first. It's going to make your life so much easier, as we found before. All right, you're going to want to state your restricted values. Meaning that I'm going to set my denominator is equal to 0 and find out what can't the variable be. Okay, so make sure you write that. So if it's x, we're going to say x can't equal. If it's y, it's y. You know, whatever your variable is, what can't we have in the bottom of that fraction? And then we're going to reduce by dividing out the common factors. Okay, so let's try this one. All right, so the first thing I noticed is that we have a common factor of 3. Now, usually we would just go to y minus 1, y plus 1, but since it's y squared, minus 1 is in both. We're going to say our final answer is 3, and y cannot equal 1 and negative 1. Okay, so let's try this one. All right, so again, I noticed that my variable is second. It's got a negative sign, so I'm going to rearrange that. Commutative property allows me to do that, so I'm going to go negative z squared plus 49 all over z plus 7. Now right away, before I do anything else, I'm going to say that z cannot equal -7 because that's what my denominator is going to be equal to 0. Okay, and I'm going to factor out that -1. So I get z squared minus 49. Yes, that makes life so much easier. Okay, and so my z plus 7s are going to be divided out. Divide. So we're going to be left with -1 z minus 7 as our final answer. Okay. All right, so why don't you try 2 and 4? 4 is a little tricky. I gave you a hard one. So check it out and see how you did. All right, let's check it out. So here we're going to factor. I wrote my what can't x be, and x minus 3, x minus 6 is my final answer. Here, this one was a little tougher. So I looked for a GCF first, which happened to be xy in the numerator and 12x in the denominator. Then I factored. And then our restricted values is 0, -4, and 3. And reduced. Okay, so we're going to use this concept to do multiplying rational expressions. Now, when we multiply, we're going to want to do exactly the same thing as what we just did. We're going to factor, and then we're going to reduce. Okay? So always start with factoring. Remember, that's GCF first, and then factoring. Okay. You're going to want to state your restricted values. Okay, now I call it cross-reduce. I'm sure there's probably a more mathematical name for that. Now this means that you're going to be able to reduce, okay, divide out the common expressions, and you can do it diagonally. Or you can also do it up down. You can never reduce across. It's always diagonal or up and down. And then whatever's left, you're going to multiply across. And final answer. Now, sometimes you may want to put it back together. In other words, multiply things. I usually don't. I usually just leave it factored, but depending on how the directions say. Okay, so let's take a look at this. So the first thing I'm going to do is a GCF. Okay, now I'm going to look at my restricted, and I look in the denominator of both fractions, and I see that a cannot equal -1 in the first fraction, nor can it equal 0 in the second fraction. Okay, so now I'm going to look for common factors that I can divide out. Well, the first one screams at me. I got a plus 1s. They can go. I can get rid of the 5s. And I can get rid of the a's. Notice I went diagonal and up and down, never across. So my final answer is 10. All right, let's try this one. Okay. First thing I'm going to do is factor, or GCF. Now this d plus 2, I'm going to write it twice. You don't have to. I find it to be helpful. And I'm going to factor out a 2. Okay, I'm going to look at my denominators and write my restricted values. So -2 and 2. Okay, now I'm going to look for common factors. So my numerator is 1. My denominator is going to be 2 times d plus 2. Or you can write this as 1 over 2d plus 4. Okay. All right. So, nope. All right, why don't you guys try 2 and 4? All right, let's see how you did. Okay, so in 2, I took out a GCF of x and factored the denominator. And my restricted values were 0, 6, and negative 6. Crossed out the x's. Crossed out x minus 6, x plus 6. Now, when I crossed out the x's, the x in the numerator went, but I have x squared in the bottom, so there's still an x there. Hence the answer 1 over x. All right, so in the second one, again, get a little harder. GCF, factor, factor, factor. And then I look at my denominators, so x can't be negative 9, it can't be 2, it can't be positive 9, I already had the 2 there. And then I reduced, divided out all the ones that were in common, and I'm left with a y and a y minus 2. All right, so basically multiplication is just a bigger version of simplifying. So let's talk about division. Okay. Again, you're going to start with factoring. So key to life, anytime you're dealing with simplifying, multiplying, and dividing rational expressions, fractional polynomials, is to factor. Okay, so then you're going to state your restricted, and I probably should have added more steps here. And in normal division of fractions, remember to flip the second fraction. Okay, and then we're going to do the multiplication process. All right, so what do I mean? So here's my problem. I don't have anything that needs to be factored here, but I am going to state my restricted value that x cannot equal 0 at this point in time. But when I flip my keep change flip thought, right, I'm going to change to a multiplication problem, and I flip the second fraction. Now that 5y is now in the denominator, so now I got to come back up here and state, y can't equal 0. Now I can reduce diagonally and up and down. So I can get rid of the 5's. For this y squared and this y, this is just going to be, there's still going to be a y left. X squared and x squared. And yes, you can do 2 into 8 and get 4. So we're left with 4 over y. Okay. All right, let's try something a little tougher here. All right, so we're going to factor first. I'm going to leave it division until I factor everything, so I can state my restricted values before I flip the second fraction. So here x cannot equal negative 3 and 3 at this point. So we get x minus 2. X plus 3, x plus 3 times, and then we have minus 3's up top. Oh, wait, one's plus. I missed that. Yep. We're okay. Okay, so now I have to add in the negative 2 here. Now, I do it before I flip, but once you get really good at this, you're going to be able to see that your restrictions are going to come from the denominator of the first, the denominator of the second, and the numerator of the second, because when you flip, the numerator becomes the denominator. All right, so let's reduce out. Okay, so I can get rid of the plus 2, and I can get rid of a plus 3, and I believe that is it. So this is x minus 2. X minus 3 over x plus 3, x plus 2. Okay. All right, let's try one more. And then you can try these. Notice, again, they have that 2 minus x. I always want to flip that around. Okay, so let's write our restrictions. So I get -1 and 1 at this moment. Now, before I'm going to flip that second fraction, but up here in the numerator first, I'm going to take out that -1 so that I might be able to reduce that out or divide that out. And we are going to be able to, okay, let's check our, all right, so I need a -5 and a +2 here. Okay, so I see an x minus 2. I see an x plus 1. I believe that's it. So -1, x minus 1. And yes, you can distribute that back in if you choose to do so. X plus 1, x plus 5. Okay. All right, pause the video and try the other two in this section now. All right, and see how you do. Okay, so for that one, right, I got y over 5 as my final answer. Restriction 7, -7, and 0. Don't forget about that y. He's the 0. And then this one, everything canceled out except a plus 8. All right, guys. Let me know if you have any questions. Remember, please keep yourself safe, and I'll talk to you again real soon.